up, everyone? It is Mr. Holt here, and today we are going to be talking about how gravity and the process of accretion functioned in the early universe to form things like moons and planets and solar systems. So let's take a look at it. So far, we've already looked at how stars form, and we've looked at the life cycle and a lot of things that happen to stars as they exist. But how do stars influence or help create solar systems or galaxies? How do large systems form around those stars? Well, we're going to look at this vortex here, and if we think of that vortex as relating to the strength of the gravitational pull of a star, right now we can see that the strength is pretty low, right? The vortex is spinning, but it's on a relatively low setting. So we can think of this as an early star that has a low gravity but can still pull things towards itself, all right? That's why we see this little dip in the vortex down here, okay? So in space, as stuff like dust and rocks and other particles are moving through the galaxy or just moving through space, they can get close enough to something like a star to be pulled closer to that object by its gravity, right? So if this is a star and we have things that travel around space or through space, if they get close enough to be pulled in by the gravity of the star, then that can stay in that system inevitably. And this is the process we're going to be looking at today, talking about how things like moons and planets and solar systems are created. So let's represent that here with some rocks. All right, we're going to be looking at a bunch of different small pieces of rocks and imagining that these are just like rocks or dust particles that are kind of traveling through the solar system, okay? So here's a tiny little rock that gets pulled in. Let me see if you guys can see the bottom of this beaker here. Okay, cool. So let's turn the gravity up a little bit. As things pass through the solar system, if that star, see how this rock is moving down here? If the star has enough gravity, it can kind of slowly start to pull things in. And what happens is, as more and more stuff gets pulled in, more and more the gravity increases more and more. Okay, so it's kind of like a cycle, but we'll take a look at it here. I'm just going to continue to drop in some small pieces of rocks every now and then to represent little pieces of rocks or some dust or other particulate matter that's flying through space that can kind of get pulled into the orbit of a star depending on the gravity, okay? Now, what happens is, as more and more of these rocks get pulled into the gravity of the star, then the rocks increase the mass of this thing, right? As the rocks are rotating and spinning around the star, then the overall system, including the star and everything that's spinning around it, increases in gravity, right? As you gain more dust particles and you pick up more rocks, the mass increases. Now, one thing that we know about mass and gravity is that as your mass increases, your gravity increases. And we can think of a great example with the Earth and the Moon, right? If you've ever seen a video of people jumping on the moon, they go much higher and they move a lot slower, right? Gravity pulls them down to the surface much slower than if you're jumping on planet Earth, because Earth is so much more massive than the moon that gravity pulls us towards the Earth and keeps us here much stronger, okay? So as this system with the star is picking up more particulates and more dust, it's actually gaining more mass, right? And as we get more mass, we know that gravity gets stronger. So I'm going to turn up the vortex here a little bit. And we can see that that makes it a little more aggressive, right? Now, if the gravity's increasing, then this vortex or this star is going to start to pull more stuff from outer space, okay? Whether it's pulling small things from further away or if it's pulling bigger things from closer nearby, basically, it's just gaining more and more stuff. And again, as it gains more stuff, its mass increases, and as the mass increases, the gravity increases. So it's kind of like a positive feedback loop in this process. So I'm going to turn up the gravity a little bit to represent that we're picking up lots of materials now. Okay? So here, we're getting lots and lots of materials. As the gravity is increased dramatically, we pick up more stuff. More stuff means more mass. More mass means stronger gravity. Stronger gravity means picking up more stuff. So it's a process that kind of repeats itself, but hopefully you guys can see how this can lead to gaining lots of things. So if all of these rock particles down here were clumped together, then eventually the gravity could force them into one clump, kind of like how fusion clumps two atoms into one atom that's bigger. The same process can happen due to gravity as things are being picked up around something like a sun or a star, all right? Now we can also visualize this with some food coloring. So I'm gonna drop a little bit of green food coloring up here, and we can see how that's taken in by the system and how it swirls around, just like we're seeing with these rocks right here. Okay, so let's see what happens with this color as I drop in some color. Okay, we can see that that color automatically got pulled in and traveled all the way around the vortex. Okay, so now it's kind of throughout the entire system, and we can take a look at that with individual drops. So I'll drop one over here and it'll pass right by the screen. Okay, so the same kind of process happens, but now it's harder to tell because the food coloring is spread throughout the whole beaker. But we can see how the accretion or the accumulation of material is kind of something that continues forcing that process to happen. So this is what we'll be looking at when we're talking about accretion and materials being picked up and brought together to form things like moons and stars, or moons and planets and full-on solar systems as well.